Welcome to our first notes video of brand new content for 8th grade. Other notes videos we've seen so far this year have been review skills, have been just like typical reminders on how to do things, have been going over homework, but this is our first video of new content that you're going to put into your notebooks to help you with your next assignment. Throughout the course of this video, you're going to see symbols throughout. You're going to see a stop sign. If you need a stop sign and you see it there, it might just be best to pause the video at that point just to finish writing down whatever is there or to try a problem. You might see a listen on those. That's just making sure that you're hearing what's going on there. If you only hear a listen or you only see a listen on any kind of part of this video, you don't need to write anything down. You don't need to stop. You don't need to do anything else. It's just kind of hearing what's next. And then you're also going to see this symbol every once in a while. Once you see this, I'm expecting that you write down the things that I'm either writing down or highlighting throughout the video. So we're going to get started in a notebook piece of paper. In your notebook, if you could write down notes, and then our title of our notes is Product of Powers. Also throw today's date, 9/17, on there. And then by the end of your notes, or before we actually start, I should say, by the time you've written, it should look like this. So notes 9/17, Power of Products. You see our symbols up here to listen and to write down. If you need to stop, stop, and then continue as we continue into our video. As we look back at yesterday's Desmos activity, this is a slide I wanted to highlight. This slide is talking about lesson synthesis. Synthesis just means what's the big picture? What was the whole purpose of it? I said a lot yesterday that we were looking at patterns. We're trying to figure out what was happening. We're trying to be efficient, use space so you don't have to count everything all the time. And this slide, I think, was one of the big things to help us put everything together to help us for today. So when we started filling in our table, we got a value of 4 for the first one because 2 to the second power is 2 times 2. 2 times 2 is 4. Then when we had this middle one in exponent, we looked at 2 times 2 times 2 times 2. That's 2 to the 4th. 2 to the 4th, when I multiply all those together, equals 16. And then when I was looking for the expanded form of 2 to the 6th, that's just taking all those 2's, 3, 4, 5, 6, writing them in one big chain and multiplying them together. When I multiply them all together, I get 64. Now, the big idea of the synthesis, or this kind of big picture, is 2 to the 6th is how many times as large as 2 to the 4th. As a quick reminder from yesterday, as we were putting that in mathematical phrasings, we're looking at 2 to the 4th times what is 2 to the 6th. And when we look at this table up here, we get an idea of exactly what to look for. So when I start seeing differences in 2 to the 4th to 2 to the 6th, I'm going to start looking over here. Because when I start looking over there, I see what 2 to the 4th is. 2 to the 4th is 2 times 2 times 2 times 2. 2 to the 6th is that same thing, 2 to the 4th, but then times another 2 and another 2. Well, what's another way to write 2 to the second, or excuse me, 2 times 2? Well, we have that here, 2 to the second. So now we could say that, in this case, 2 to the 4th times 2 to the second equals 2 to the 6th. Well, why could that possibly be true? Well, we have right here, 2 to the 4th times 2 to the second. What does that equal? Well, it's 2 to the 6th. It's right here. So now our final idea here is how many times as large is 2 to the 4th to 2 to the 6th? It's 2 to the second. I'm sorry for the hard to read text there, but 2 to the second. What's 2 to the second? Well, that's 2 times 2. What's 2 times 2? That's 4. So 2 to the 6th is 4 times as large as 2 to the 4th. You could also say that as 2 to the second times as large. So when we started looking at all these big chains of events and all these different things, we can use exponents to talk about growth. We can use exponents to talk about differences. We can use exponents to talk about how we can get from one group to the next. So when we start looking at how many times as large, we're going to start seeing some connections between 2 to the 4th and 2 to the 6th, and this little connection here with 2 to the second. First is I'm going to highlight some stuff here, and this is going to be your first thing that you're going to stop and write down into your notes. So on that notebook document, you have your title, you have Power of Powers, or excuse me, Product of Powers up here. And then you're going to have a definition. So your definition is to multiply powers with the same base, you're going to add your exponents. And we'll justify that, and we'll talk about what that means. So I'm just going to have you write down those highlighted sections. Then on the next page, or on the next slide, I'm going to show you a sample. So if I'm going too fast, stop and then just make sure you have that down, hit play again, and I'll continue on to the next sample. But I'm going to write down this and not have and go kind of step by step, and you're going to kind of follow along with me. So at this section, you're going to stop and you're going to write down as I'm writing things down. And if you can format them the way that I do, I think it'll make a little bit more sense as to what we mean when we say add the exponents. So our example problem that you're putting in your notes is right from the book. We're going to put 3 to the second power times 3 to the fourth power. And we have them in exponent value. Rather than solving 3 to the second, 3 to the fourth, and then multiplying together, we have a shortcut where we can keep everything in exponential value, and now we can talk about huge numbers in many different ways. So in order to understand this the absolute best, I'm going to write it down in expanded form really quick. 3 to the second is 3 to the third, or excuse me, 3 times 3. I bring down my multiplication sign, and then 3 to the fourth in expanded form is 1, 2, 3, 4 threes with multiplication signs in the middle. So we just broke down the problem into 3 sections. So now as I look at what's happening there, if I look at this line right here, I'm going to record and I'm going to say, well, hey, I have this multiplication sign in the middle. That's 6 threes, and if you could jot this down, all being multiplied together. Six threes being multiplied together is equal to 3 to the sixth. So we know that. So now our shortcut and our rule, and again, I'm going to zoom out a little bit, so if you need to see this a little bit more, stop and just make sure you get all this into your notes, but I'm going to zoom so I can write a little bit more. So then the shortcut would be we go back to the original problem. The original problem was 3 squared, or 3 to the second power, times 3 to the fourth. And then now to end up, we know the answer is 3 to the sixth. The shortcut is that when we had the same bases, 3, I can just add the exponents. So 4 plus 2 got me 6, and that was my shortcut. And so we kind of proved why that works because we have our expanded form right there. 3 times 3 times 3 times 3 times 3 times 3 was equal to 6 threes. So now we could kind of justify in this version why we're getting that answer or why we're able to add our exponents. So I'm going to keep moving forward, stop, record, make sure you get this into your notes. At this point, your notes should look like this as we had them taken care of. So if you need to, make sure you stop and get these taken care of. And then the last thing we're going to take a look at really quick is looking at 3 very quick problems. If you want to see me solve A and B and want me to slow down a little bit, then we can go back and check out some of those examples, or you're going to go to your page in your math book and you're going to look at page 24 and you're going to look at some of those purple tutor, and my drawing's going to be terrible, but you have those tutor buttons in purple. Those are all clickables. Those are all kind of walkables through different examples too. So what we can look at here is I'm just going to use my shortcuts now to solve. So I have same bases of 9, so that's 9 to the third times 9 to the second. I'm going to add my exponents, 3 plus 2, 9 to the fifth. In the letter B, I have A and I have A, same bases, great. I'm multiplying them. That means the shortcut in exponential form is add the exponents, A to the fifth. And then lastly, in C, we're seeing a different connection of things. So you can just keep listening. Otherwise, if you want to put this example in your notes, that's great too. But I'm just going to write it a little bit larger. That's a terrible color for this background. We have -2 times m being multiplied by -8, which is being multiplied by m to the fifth. So we have kind of a messy example here, but what I'm going to rewrite it as is just one gigantic multiplication chain, because for me, that makes a little bit more sense as to what we're looking at. So here, I know I can't multiply -2 and m together because we don't know what m stands for. But what I can do is I can multiply m and m to the fifth together. And that is the same as, I'm just going to rewrite this down here, 1 times 1, 2, 3, 4, 5 m's. Because I have 5 m's there being multiplied by 1 m there, and I'm connecting that there to equal m to the sixth. Because now I just have 6 m's being multiplied together. So really we were seeing almost like an invisible 1 as our exponent, and then just adding those exponents together. So m to the sixth. Then I still have to add my other bases. Since I can't multiply them. Since I can't multiply these by any m's because they have different bases, I can multiply numbers together. -2 times -8 is positive 16. And so now my final answer, and I can't go further, is 16m to the sixth, because I'm still multiplying those two together from the original problem. So now I'm just kind of condensing things into an exponential form to get to my next step. So 16 times m to the 6th, or 16m to the 6th. So hopefully this video helps understand some different things as we go. You have tutor videos in your book, and you have some examples as you kind of walk through those as well. So product of powers, our shortcut is when bases are the same, add the exponents.